Dear friends, welcome back to Data Analytics Talks. In this session, we are going to discuss on DAX. I'm not sure you have heard about DAX in Power BI. DAX means Data Analysis Expression. DAX is the language of Power BI. DAX is the language of Power Pivot. DAX is the language of SAS Tabular. If you have already worked in Excel Power Pivot, I'm sure you should have some experience with the DAX. If you know DAX, developing in Power BI is quite easy. DAX is simple but not easy. If you are new to DAX, don't expect to learn DAX in few hours. It will take its own time. You should not try to learn it in the same way as you learn other languages. I'm sure this video will help you to learn it. Those who already in it can make your knowledge solid. Often we learn DAX in the same way we learn other languages. DAX requires you to study theory, and most of us don't like to learn theory. Am I right? If you don't learn it properly, you will end up in seeing wrong numbers, where the major focus of the dashboard is correct numbers. So what is a DAX? Data Analysis Expressions is a formula expression language. It's a library of functions and operators that can be combined to build formulas and expressions in Power BI, analysis services, and Power Pivot in Excel data models. DAX formulas included functions, operators, and values to perform advanced calculations and queries on data in related tables and columns in tabular data models. Where are we using DAX? DAX formulas are used in measures, calculated columns, calculated tables, and rollable securities. If you are new to DAX, the best resource you should refer is Microsoft site itself. You can find so much details in the Microsoft Learning Portal, where learn.microsoft.com/en-us/DAX. And you can start from the DAX overview. Then you have a lot of videos that is explaining you DAX, and you have sample models, you have best practices, and a lot of things you can find under this overview. Coming back to the presentation, I would like to show you a simple formula where I calculate total quantity using the sales quantity column in the sales table and using a function called a sum. I would like to return total quantity multiplied by 0.95 if the total quantity is greater than 1000, if not 1.25. So what is important is the formatting. People often write their formula into single line in Excel, which is really impossible to read. But in Power BI, we have the ability to make it in multiple lines, which give more readability. In the formula bar, if you use Shift Enter, it creates a new line. So whenever you are writing a formula, make use of the multiple line feature in Power BI. Next, let's look into some code snippet written in DAX. What is it doing? This is calculating total quantity. This is calculating total sales. This is concatenating two variables. This again making a comparison. Then this one is evaluating and applying filter. So from this, what are you understanding? We can understand that DAX, like any other language, is a programming language. It has data types, it has operators, it has functions. Getting an understanding about the data types, operators, and functions is a must-have for becoming DAX expert, I will spend some time going through these data types, operators, and functions. Again, I would like to recommend you to the Microsoft Learning Portal, where you can learn in very detail about the Power BI desktop data types, which are numeric, datetime, text, true or false, blank, binary, table types, and so on. So it gives you examples, it gives you details about each data type, and even from the numeric data type, there are decimals, fixed decimal, whole number, and finding the accuracy of number type calculations, date type, text type, case sensitivity. Everything is well explained in this learning portal. Again, I recommend you go to this portal and spend some time, understand various data types available in DAX, and start using it. Coming back to my Power BI desktop, in the table view, I can see how data is loaded into the Power BI. If I go to the transform data using Power Query, I can understand that as soon as the data is loaded into my data set, the data types are identified and updated automatically. But I can always go to the data type where we have the default data type, and we have a decimal, fixed decimal number, whole number, percentage, date or time, date, time, time zone, duration, text, true or false, binary. So I can switch my data type into any of the other data types by selecting the column and changing the data type into some other type. For example, I have a unit price column. I can change this into a whole number if needed. So the decimals has been removed and this became a whole number. I can revert it back again. This is the original column type. As a programming language, DAX provide you the flexibility to change your data types. As soon as you create a new column, you can specify the data type. Whenever you are creating a table, you can specify the data type and make sure you understand the concept of data type in DAX. Another important topic that every programmer should know is operators in DAX. You are aware of the arithmetic operators like plus, minus, asterisk, forward slash, caret, and some of their examples I will show you later. And we have the comparison operators like equal to, strict equal to, greater than, less than, greater than or equal to, less than or equal to, not equal to. And we have the test operators like ampersand for concatenating two text variables. Then we have the double ampersand, creates an AND condition between two expressions that each have a Boolean result. And we have the double pipe symbol and in symbol. These are the common operators being used in DAX. So as I already said, please go to Microsoft Learning Portal and explore more about types of operators, their examples. This will really going to help you excel in the DAX programming field. Coming back to my Power BI desktop, I would like to show you how these operators work in the real world. I have added a couple of cards which is showing add, division, subtract, multiply, power. and also concatenate. Then there is a operator overloading, then some date functions. So how the add function work? You are seeing 12. It is because I am adding 5 plus 7. This plus operators is adding the two numeric values 5, 7 equals 12. What about division? It is dividing 21 by 7. We are getting 3. So we are using the division operator. Then we in the multiply, we are using 7 multiplied by 5. You are getting 35. The operators we are using is into. And we have the power. We are using 10 raised to 2. That is 100. Then we have the last one subtract. We are subtracting 7 minus 5. We get 2. So these are the common numeric operators. And these are our measures. Then coming to the concatenate, it's basically a text function. So we are using the ampersand and we are adding two text like play and football. So result is play football. And we have date functions. We can create a date measure and we can generate some text data. For example, we can say the starting date and we can say the ending date. So this will generate a table from 2016 January 1st to today. It is basically a date measure. We can use the today function to get today's date, that is 22nd 8 2023, and we have tomorrow, today plus 1, that is tomorrow 23 8 2023, and we have yesterday, today minus 1, that is yesterday 21 8 2023. So these are some of the arithmetic operators that we are using, and also there are overloads. In the overload, even though the numbers are within double quotes, if you use plus, it will add as numbers like 5 plus 4 equal 9. But if you use numeric values 5 and 4, but you are using ampersand, this will be considered as a concatenation. Okay. Similarly, there is also how do you refer a column in the expression, that is basically you are using the sales order details table and you are using the order quantity. We are giving the single quotes because there is a space between this name. So if there is no space, ideally there is single quotes are not even required. So this is how we are referring a column in a formula. So when there is a space, we can use single quotes to wrap that in. Okay. So these are some of the operators that very commonly used in DAX. As there are multiple operators, it's always important to understand about the operator precedence. So you have the exponentiation, then sign, then multiplication and division, then addition, subtraction, then concatenate two strings of text, then comparison, then not. So this is the operator precedence. So far we have been seeing DAX operators and data types and some examples. Next, I would like to introduce you to DAX functions. A DAX function is a predefined formula that performs a specific calculation on the data in the data model. And I already mentioned that DAX stands for Data Analysis Expression, and it is a collection of functions, operators, and constants that can be used to create new information from data already in your data model. So today I will introduce you to Microsoft Learning Portal, where you can refer numerous DAX functions. Generally, DAX functions are categorized into aggregation function, date and type function, filter function, financial function, information function, logical function, other functions, parent and child functions, relationship functions, statistical function, table manipulation function, text function, time intelligence function. It's not practical to go through each and every one in this section like this. Just like DAX operators and data types, I would recommend you to go to Microsoft Learning Portal, where you can find DAX functional references, and you can find more than 250 functions which are used in data analysis expression formula under various categories. You can explore them one by one, like aggregate functions, examples like count, count A, max, min, date functions like date diff, date value, day, month, minute, then filter like calculate, all except. Then we have the financial functions like PMT, PPMT, PV, rate, received. Then we have information functions, math functions, statistical functions, median, mean, mode, then rank. Then we have table functions like distinct, accept, filters, generate, group by, ignore, and text functions like exact, find, fixed, format. All these are functions which has expected outcome and input parameters. It's not practical to go through each one of them in this session. I recommend all of you go and spend some time deep diving into the DAX functions. Before we close this session, I would like to call your attention to the formula syntax which you are going to use it. We have a simple formula, sum of sales amount equal to sum of fact sales amount column. So this is marked by A, B, C, D, E, F, and we will see each one by one. What is A? The measure name sum of sales amount. Measure name sum of sales amount. Formula for measure can include measure name followed by a colon followed by calculation formula. Then second one, B is equal sign operator, indicates the beginning of the calculation formula. When calculated, it will return a result. Then C, the function sum adds up all the numbers in the sales amount column. This is a sum function. And we have the parenthesis like D, surround one or more arguments. All functions requires at least one argument. An argument passes a value to the function. This one and this one. This is the argument basically. Fact sales amount is argument. Then we are referring to E. What is E? It's a table reference. Fact sales is a table reference. And what is F? It's a reference column sales amount in the fact sales table. With this argument, the sum function knows on which column to aggregate a sum. So this is the fact sales amount column. Using this column, this sum function aggregates a sum. So this is the basic formula syntax. I am sure you will be, as a DAX developer expert, you will be start using this syntax from now on. Thank you very much for watching this video. Let's learn together. Thank you.